Welcome to FEU Tech Video Courseware. Modulate. Bolted connection. Connection types. Classification based on type of resultant force transferred. Concentric connections. Eccentric connections. Connection types. Classification based on type of force in the bolts. Lap connection, butt connection. Here is an example of bolted connection. Connection details. A. Shear connections. Beam checks all properties, for example bolt bearing. B. Interconnector checks bolts, welds. Connector checks shear rupture, block shear, bolt bearing. Connector to support checks, if bolted, same as checks on beam to connector. Support local checks, bolt bearing, if column web, V1 plus V2. Beam to column connections. A. Simple, transfer only shear at nominal eccentricity. Used in non-sway frames, with bracings etc. Used in frames up to 5 stories. B. Semi-rigid, model actual behavior but make analysis difficult. However lead to economy in member designs. C. Rigid, transfer significant end moments undergoing negligible deformations. Used in sway frames for stability and contribute in resisting lateral loads and help control sway. Beam to column connections. Economical when automatic saw and drill lines are available. Check end bearing and stiffness of seating angle. Clip angle used for torsional stability. If depth of cleats 0.6 design bolts for shear only. Eliminates need to drill holes in the beam. Limit depth and thickness. T/2, GR.8.8, and /3, GR.4.6. Rigid beam to column connections. A. Short end plate. B. Extended end plate. C. Haunched. Connection details. B. Moment connections. Beam check for flexure, if bolted flange plate, consider reduced flange area. Flange connection checks. A. If directly welded flanges, check CJP weld. B. If bolted plates. Beam to connector checks. Connector checks, either flange plates or angles. Connector to support checks. Supporting column. A. Doubler plates. B. Stiffener plates. Shear connection, eccentricity should not be considered. C. Brace connections. Brace checks, tension capacity, compression capacity, tear out, if bolted. Brace to gusset, connectors checks, bolts, welds. Gusset plate, connectors checks. Force distribution, uniform force method or UFM. Gusset plate to column connection. A. Gusset plate checks. B. Gusset plate to connector checks. C. Connector checks. D. Connector to support checks. E. Support local checks. D. Truss connections. Beam check for flexure, if bolted flange plate, consider reduced flange area. Flange connection checks. A. If directly welded flanges, check CJP weld. B. If bolted plates. Beam to connector checks. Connector checks, either flange plates or angles. Connector to support checks. Supporting column. A. Doubler plates. B. Stiffener plates. Shear connection, eccentricity should not be considered. Beam connections similar to beam column connections. Moment continuity may be obtained between secondary beams. Check for torsion in primary beams. Issues on connection design. Traditional analysis assumptions. Connection elements are assumed to be rigid compared to the connectors. Connector behavior is assumed to be linearly elastic. Distribution of forces arrived at by assuming idealized load paths. Provide stiffness according to their assumed behavior. Ensure adequate ductility and rotation. Capacity. Provide adequate margin of safety. Force transfer mechanism. A. Bearing connection. B. Friction connection. Bolts under tension and prying effect. Bolt hole standards. Failure limits. A. Bolt shear planes, basically any plane that transfers shear. Bolt shear capacity is dependent on the number of shear planes in a bolted connection. Typical connection is either in single shear or double shear. B. Bolt threaded part. Bolt shear capacity is also dependent on whether the threaded part of the bolt is included, N, or excluded, X, from the shear plane. Bolt designated as N or X are only applied on bearing-type connections, that is, in snug-tightened or pre-tensioned joints only. C. Block shear rupture, a limit state in which the failure path includes an area subject to shear and an area subject to tension. This limit state is so named because the associated failure path tears out a block of the material. D. Bolt bearing. Concerned with the deformation of material at the loaded edge of the bolt holes. Bearing capacity of the connection is influenced by the proximity of the bolt to the loaded edge. This limit state is applicable to each bolted ply of a connection. E. Shear yielding and shear rupture. Most connections are subjected to the shear component of the loading. Even moment connections must have provisions for shear transfer. Thus, those elements in the connection that are subject to shear forces must be investigated for shear yielding and shear rupture. Both will apply regardless of fastening method, bolt or weld. F. Flexural cope buckling. When a beam is coped, the reduced section modulus of the remaining beam cross-section may significantly reduce the flexural strength of the member. Bolted connection joint types. A. Bearing type connections. Snug tightened connections. In this connection type, it is required that the fang surfaces or contact surfaces of the connection be brought into firm contact. This can be done by a few impacts of an impact wrench or the full effort of a person using an ordinary spud wrench. Bringing connected materials into firm contact needs some pretension on bolts, but in snug tightened connections there is no specific requirement for a level of pretension that must be induced into the bolts. The clamping force created by snug tightening the bolts is not sufficient to prevent slip in the connection. That is why this type of connection is applied where slip is non-detrimental to the serviceability of the structure. One common application of snug tightened connections is for a simple beam shear connection to column or girder, in which the beam requires end rotation to minimize the transfer of moment. Thus, slip of the joint is desirable because it permits rotation. The bolts in a snug tightened connection are always assumed to be in bearing against the base material, thus the connection is defined as a bearing type connection. Pretensioned connections. This connection type generally is just like a snug tightened joint, except that bolts are required to be fully tensioned once the firm contact of fang surfaces has been achieved. Full tension means that the bolt is tightened or torqued until a tension force of approximately equal to 70% of its tensile strength, per RCSC, is produced in the bolt. A pretensioned connection is still considered a bearing type connection. This is commonly applied to connections where pretension is required regardless of whether or not the potential for slip is concerned. The combination of bolts and welds sharing the same force on the same fang surface. Bearing type connections use only 50% of the bolt capacity. Slip critical connections full capacity of the bolts can be used. And that's the end of Module 8. Thank you for watching.